Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discuss about one of the solid fuel, coal, and what are the analysis. So, there are two types of analysis, proximate and ultimate analysis. We are going to focus mostly on the ultimate analysis of coals in coals. Why it has to be analyzed? So, what are the reasons to analyze these coals? Coals are tested before or before its usage in industry. So, some markets have required some specific quality characteristics for the process of coal, and it will be used before analyzing and before the estimation of all the carbon content and the volatile matter and the ash content and the moisture content. They are analyzed before its use in industry. They have some environmental regulations, also causes knowledge of a coal's quality. Some products also require analysis of physical characteristics of coals before handling and processing. There are some standard tests made by this ASTM. ASTM means American Society for Testing of Materials. So they set some standardized protocols for sample preparation and analysis, and these are under certified laboratories. So what are the common coal analysis, which include this proximate and ultimate analysis. So this analysis of coals using ASTM procedure is helpful in its ranking and the classification and quality of coal and elemental analysis as well as industrial applications. So, based on the analysis of the coal and the results obtained from this analysis, we can rank the coals accordingly, and we can use it in industries according to their applications. Proximate analysis. In this analysis, the percentage of carbon is going to be determined indirectly. It is a qualitative analysis of the following parameters, like we know. So the moisture content is nothing but the amount of water molecules present or absorbed by the coal. Suppose it is X. The volatile matter is nothing but which is volatile at 900 degrees centigrade. Then the resultant is Y. If the ash is in this process, the coal is continuously allowed in a cyclic process, first weighing the sample, then heating, then cooling in the desiccator, then weighing. Again, so in this here moisture content is found out in 105 to 110 degrees centigrade. Then the weight loss is calculated as X. In volatile matter, it's around 750 degrees centigrade. In electric furnace, it was heated. Then the weight loss it was calculated in percentage as Y. In ash, muffle furnace 900 to 950 degrees, it was heated. Like first sample, heating in muffle furnace, then cooling in desiccators, then weighing. So it will give some value, suppose A. So again, this sample is again heated in muffle furnace, then followed by cooling and weighing. Once done, again the step is repeated, again muffle furnace, cooling, desiccator, until the constant value is obtained. So this process is repeated until the constant value or constant weight of the coal is obtained. Means the coal present in the sample is constantly and continuously heated until the whole ash formation. So once the constant value came means, so the resultant, this is a crucible with the ash. So there is no further ash is formed. no ash is not forming further. Then the weight of this ash is taken as jet. So this is the jet. So fixed carbon means generally this fixed carbon is calculated accordingly 100% minus the percentage of moisture content means X, volatile matter means Y, ash means jet. So this is an indirect measurement for the carbon concentration or the carbon content in the coal. This is all about the proximate analysis. So on combustion, what happens? This carbon dioxide, hydrogen, so volatile matter, all these salts are lost by the heating at 700 to 750 degrees centigrade. So ultimate analysis. This is what we are going to focus mainly on this presentation. So this is the elemental analysis, often called as qualitative analysis of coal. So the proximate analysis is quantitative, whereas ultimate is qualitative analysis. This is quantitative and this is qualitative analysis. Whereas proximate moisture, volatile and ash content we are going to see, whereas in ultimate we are going to see the elemental composition. So we are going to see the elemental composition like for carbon, hydrogen, oxygen, sulfur, how much percentage of this content of these elements like carbon, hydrogen, oxygen, sulfur we are going to see in this ultimate analysis. This provides a convenient method for reporting the most major organic elemental composition of coal. So the analysis involves the determination of carbon C, hydrogen H, nitrogen N, sulfur S and oxygen O. We are going to determine individually this carbon, hydrogen, nitrogen, sulfur followed by oxygen. For this analysis, a coal sample is combusted in an elemental analyzer which measures the weight percentage of carbon, hydrogen, nitrogen, sulfur and ash from a coal sample. In general, with the instruments with the high laboratories with the high-end equipments called elemental analyzer is used. In that we can directly find out the carbon, hydrogen, nitrogen, sulfur and ash from a coal sample directly. This is the elemental analyzer. Here generally ONH analyzers, CS analyzers which are individual, whereas in ONH analyzers oxygen, nitrogen and hydrogen can be calculated at a single stretch or a single sample from a single sample, whereas in carbon sulfur analyzers carbon and sulfur can be get in a single stretch or using a single sample. So the first thing is carbon and hydrogen analyzing in general laboratory method. So 1 to 2 gram of accurately weighed coal sample is taken and burnt in a current of oxygen in a combustion apparatus. This is the combustion apparatus, means the combustion reaction is going to take place inside this reaction and pure oxygen. So this is O2 supply. This is the combustion tube and platinum sample in a platinum container. Why? Because this platinum won't be react much easily with other. So mostly these platinum crucibles are used for these metallic extractions, even for the coal, the carbon and hydrogen estimations. So this is made up of platinum. So sample in a platinum container. So 1 to 2 gram of sample is taken inside this crucible, then heated and pure oxygen supply is given in a combustion tube. So what happens? The gaseous product, the carbon and the hydrogen of the coal are converted when it mixed with the oxygen. So the carbon in the coal and hydrogen in the coal mixed with the oxygen, they convert into CO2. They reduce it to CO2 and H2O. So here of O2. So the reaction is CO2 and H2O are the resultant products. So the gaseous products of combustion are absorbed respectively in KOH and calcium chloride tubes of a known weights. So what happens when the coal is mixed with oxygen? The oxygen in the combustion tube reacts with the coal, carbon and hydrogen content. The content of the carbon and hydrogen will mix with the oxygen, results in the CO2 and H2O formation. Based on the formation of the CO2 and H2O, we are going to find out the carbon and hydrogen atoms or elements present in the coal sample. So the simple reaction is the carbon weight is 12. Whereas when it compared, this is 18. 16 into 2. Here carbon is 12 and here the resultant is 44. So the weight, the conversion of this carbon into CO2, so increased weight. So the formation of this CO2 gives the percentage of carbon and hydrogen. Whereas coming to the hydrogen reacts with the oxygen and gives water. So the hydrogen is 2, whereas in water is 18. So 2 molecules of hydrogen, 2 plus 16, 18. Whereas here 2 molecules, 16 into 2, like 32, and then 32 plus 12 gives 44. So the oxygen molecules, 32 plus carbon gives 44. Here 2 plus this is half oxygen gives 18. So this is 16. So 16 plus 2 gives 18. So 2 KOH. So whatever the carbon dioxide formed will be the formed carbon dioxide is gaseous. So once here in the furnace it enters into this anhydrous calcium chloride and KOH solution. So this carbon dioxide reacts with the KOH and gives K2CO3 plus H2O. So based on the weight of K2CO3, we can find out the carbon and hydrogen content in the coal sample. The same criteria, the water formed in the furnace passed through the anhydrous calcium chloride tubes, where the calcium chloride react with the water molecules, results in the calcium chloride heptahydrate. So based on the weight formed from these tubes, we can find out the hydrogen content in the coal. So the percentage of C is equal to increase in weight of the KOH tube. So because the carbon is reacted with oxygen and yielded CO2. So the percentage of C, the CO2 is absorbed by KOH. So the increase in weight of KOH divided by the weight of the coal sample taken at the starting of the experiment or the starting of the reaction into 12. This is the carbon molecular weight and CO2. This is the molecular weight of the 44 is the molecular weight of the carbon dioxide into 100 gives the percentage of carbon present in the specific sample. Then the percentage of H. So the increase in weight of calcium chloride tube, because the H reacts with half oxygen gives H2O. So that H2O was absorbed and reacted with calcium chloride present in the tubes. Then it is yielded calcium chloride heptahydrate. Then the increase in weight of the calcium chloride tube divided by weight of the coal sample taken into, here 2 is the hydrogen molecule and 18 is the water molecule molecular weight. 2 by 18 into 100 gives the percentage of hydrogen present in the coal samples. Next element which we are going to find out is nitrogen. Here 1 gram of accurately weighed powdered coal is heated with concentrated sulfuric acid with K2SO4 as a catalyst in a long-necked Geldar's flask. So if Geldar's flask is used, then it is called the Geldar's experiment, where the sample like 1 gram plus sulfuric acid is a strong concentrated sulfuric acid in the presence of K2SO4, which acts as a catalyst and enhances the reaction in a faster rate. This catalyst plays a role like they enhances the reaction in a longer rate. Gives the clear solution plus KOH. Again heating gives ammonia plus acid. Then non-consumed acid. So the non-consumed acid present in the solution will be back titrated. Then the consumed, so by titrating against the non-consumed acid plus base gives the consumed acid. So indirectly we are measuring the acid consumed to neutralize the nitrogen, means ammonia present in the, so the nitrogen present in the coal is converted into ammonia and acid will be released because we use H2SO4. So here base OH molecules was attached and ammonia was nitrogen is reduced to ammonia, then acid, then the non-consumed acid plus base was back titrated, then the consumed acid means the amount of acid consumed to neutralize the base is measured. So after the solution becomes clear, the excess of KOH and the liberated ammonia is distilled over and absorbed in a known volume of standard acid solution. So the unused acid is then determined by back titration with standard NaOH solution. So if it is a base, we have to titrate with acid. If it is an acid, we have to titrate with base. By the above process, we can measure how much volume of acid consumed to neutralize the base NaOH. This is an acid-base titration. So we can know the how much volume of acid consumed to neutralize the base solution. So once all the base ions means OH minus ions in the solution completed, the excess of acid got released into the solution. We can measure the amount of acid present, then we can know the value. So from the volume of acid used by ammonia liberated, the percentage of N in coal is calculated as follows. So the volume of acid consumed into, suppose it is X, so X value, and normality of acid, suppose it is 0.1 N or so the normality of the acid, then into 1.4 into divided by weight of coal sample taken. This gives the percentage of N in coal samples. Sulfur. The known weight of coal is combusted in a bomb calorimeter in the presence of barium chloride. So the amount of coal, suppose 5 grams of coal has to be mixed with barium chloride, and then the combustion has to be done in a bomb calorimeter. If any sulfur present in the sample is converted into barium sulfate. So the barium chloride reacts with the sulfur, it displaces the chlorides, so it released in the chloride gas form, then it go and attach with the barium compounds and the barium sulfate is formed. So the barium sulfate is separated as solid and measured its weight. So the sulfur plus oxygen gives sulfate ions. So once these ions mixed with barium chloride, then barium sulfate is formed. So the percentage of this happens fully in the bomb calorimeter. So the percentage of S is calculated as weight of BaSO4 obtained. So the obtained barium sulfate, because the sulfate ions present in the coal reacted with the barium. So the weight of the barium sulfate was taken, and the initial weight, suppose 5 grams, is taken in the bomb calorimeter into molecular weight of the sulfur and molecular weight of barium sulfate into 100 gives the percentage of sulfur present in the coal sample. So by multimate analysis of coal percentage, carbon, hydrogen, nitrogen, sulfur, ash, oxygen in the coal can be calculated. So the percentage of ash. So the same thing, ash determination is carried out proximate analysis. So a percentage of ash will be obtained in the quantitative analysis itself, which is approximate analysis, which gives the percentage of ash by the continuous procedure like heating at 900 degrees centigrade, then cooling, then weighing. Again heating, cooling, weighing. Again heating, cooling, weighing. So the constant value will come, so which will give the ash content. So from there we have to take the percentage of ash, weight of ash left into 100 by weight of coal taken initially. Then percentage of oxygen. As up to now, carbon, hydrogen, nitrogen, sulfur, ash. So all these 5 elemental analysis we have done. Now the percentage of oxygen is nothing but the 100 minus percentage of carbon. This is carbon, hydrogen, sulfur, nitrogen. This is ash. So it is an indirect measurement. The oxygen is an indirect measurement. So if the 100 minus the percentage of all these molecule elements gives the percentage of oxygen in coal. So C is the increase in KOH tube by weight of coal sample taken. 12, this is carbon weight, and carbon dioxide molecular weight into 100, whereas percentage of H, this is an increase in weight of calcium chloride tube because the hydrogen was converted into water molecules. These water molecules are absorbed by calcium chloride and formed calcium chloride heptahydrate, which is the weight of calcium chloride tube. So the oxygen hydrogen is molecular weight of 2. 2 is the molecular weight of hydrogen, whereas water carries a molecular weight of 18 into 100 gives the value. Whereas in percentage of N, volume of acid, normality of acid by weight of coal sample gives the percentage of nitrogen, whereas in percentage of sulfur, weight of barium sulfate obtained by weight of coal sample taken in bomb calorimeter. Here the sulfur is converted into SO4 2- ions, reacted with barium chloride, resulted in formation of barium sulfate. This weight of the barium sulfate is taken, divided by the initial sample weight into 32 molecular weight of sulfur and 233 is the molecular weight of barium sulfate into 100 gives the percentage of sulfur. Whereas all this percentage sum plus 100 gives the oxygen percentage. Gives 100 minus the percentage of all this 4 plus ash. Gives, so 4 plus 5, these are the 4 elements, plus ash content, ash percentage, so 100 minus 5, 4 elements plus ash percentage gives the percentage of oxygen present in the coal. So the elemental composition of coal is determined by this, oxygen elemental composition is determined by this procedure. So what are the significance of, what is the importance of this ultimate analysis? Carbon and hydrogen, the greater the percentage of hydrocarbons like carbon and hydrogen, better is the quality and calorific value of the coal. As we know, the fuels, all the fuels are hydrocarbons. So the more the more the carbon and hydrogen content, the more is the quality of the fuel and the more is the calorific value. Nitrogen. Nitrogen has no calorific value, hence presence of in coal is undesirable. So it won't have calorific value. So the nitrogen is considered as undesirable in this process. Thus, a good quality coal should have very little nitrogen content. So this is not an desirable compound, so its presence should be expected in very low content. Sulfur. Sulfur, although contributes to the heating value of coal, yet on combustion produces some acids like sulfur dioxide and sulfur trioxide, which have harmful effects on equipments and also causes environmental or atmospheric pollution. So the sulfur is usually present in 0.5 to 0.3% and derived from ores like iron pyrites, gypsum, etc. mines along with the coal. In the earth's crust, when this coal is mixed with all these elements like ores like iron, pyrites and gypsum, this coal derives some of these ores and this results in the composition of sulfur in their coals. So the presence of sulfur is highly desirable because it forms sulfuric acid and sulfur trioxides in coal, making environmental pollution as well as damage to the equipments, and hence it is highly undesirable and used for making coke of our iron industry. Especially in making of coke in iron industry, this sulfur is highly undesirable since it is transferred to the iron metal and badly affects the quality and properties of steel. So this is pyrite is nothing but the iron sulfates. So this causes the bad effects on the quality and properties of the steel formation. Moreover, oxides of sulfides like pollute the atmosphere and lead to the corrosion in the equipments and the materials used in the industry. Ash. As we know, ash is a useless and colorless and non-combustible matter which reduces the calorific of the coal highly. Moreover, ash causes the hindrance to the flow of air and heat, thereby lowering the temperature of the furnace or the reaction which we are using in the industries. However, lower the ash content, better is the quality and ranking of the coal. The presence of ash also increases the transport, handling and storage problems, and once the ash formed becomes a big problem to the industry for their disposal. The presence of also ash also causes early wear of furnace walls and burning apparatus. So it damages the apparatus and the equipments and furnace walls easily. This presence makes problematic situations in industries. Oxygen. The oxygen content decreases the calorific value of coal. So the more is the oxygen, the calorific value will be less. So it's this high oxygen content coals are characterized by high inherent moisture, low calorific value and low choking power. And moreover, oxygen is low cooking power. Moreover, oxygen is combined form with hydrogen in coal and thus hydrogen available for combustion is less than the actual one. An increase in 1% content decreases the calorific value by 1.7% and oxygen is undesirable. So sulfur is undesirable, nitrogen is undesirable and oxygen is non-desirable. So these sulfur causes sulfates and so this causes pollution. And nitrogen also don't give high calorific value, so it is not desirable. It is undesirable. Oxygen causes 1% decrease in 1% increase in causes 1.7% of calorific value is decreased by 1.7%. So these three elements are undesirable in the coal analysis in coal formation. So another thing is carbonization of coal is the most important use of coal to produce coke, mostly for metallurgical purposes. So when coal is heated in the absence of oxygen, this is called the carbonization process. So solid example coke, liquid form example fuel oil and gas example coal gas, mixture of these methane, hydrogen, carbon monoxide and carbon dioxide. Then bituminous coal is used for this carbonization process. When bituminous coal is heated strongly in absence of air, especially oxygen, the volatile matter escapes out and a lustrous, dense, strong, porous and coherent mass is left, which is called the metallurgical coke, which is having high demand in metallurgical industries. The most important industrial use of coke in the metallurgical industry is especially in the blast furnace. They are used especially in the blast furnace in metallurgical industry. What are the uses of coal? So the coal for electricity generation, we can use the coal for electricity generation and to make coal and steel and specialty products and chemicals and industrial and residential markets and rare elements from these coals. So in the electric power distribution. So the coal for electricity generation, where the coal is carried through a conveyor belt and it enters the crushing and pulverization process, enters the boilers and the steam is collected here, then it enters into the turbines, then generator, then transformer, then the electric power distribution. Here this reaction is cooled continuously by a cooling water. So these are the solid wells. So by the steam generation, in the cooling water, the coal is useful in the electricity generation. So the coal to make coke and steel. So the important raw material used in steel making process. So very small amounts of coal. So compared to the electricity production in steel, very small amount of coal is required. This coal is used to make steel is heated in an oven without air at temperatures of 2060 degrees Fahrenheit. So until most of its volatile matter is released. At this temperature, it releases almost all of the volatile matter releases at this temperature. During this process, it softens and liquefies and resolidifies into a hard porous material called coke. So at this temperature, what happens first? Liquefies, it becomes into liquid, then resolidifies and first softens, liquefies and resolidifies. Here if we see met coal, iron ore and limestone, all are used for steel preparation. Then here coke formation. The coke formation is enters into the blast furnace. So first what happens, this coal is softened and then liquefied and resolidified to form a hard porous material called coke. This is not, the coke is a porous carbon rich material used to make steel. The coke is mixed with iron ore. So then the thus formed coke is mixed with the iron ore and limestone to make molten iron. Here coke plus, this is not the coke which we took, not the soft drink. This is a highly porous material, coke plus iron ore plus limestone react in the blast furnace, then molten iron, then the basic oxide furnace, it enters into the basic oxide furnace, then the steel is formed. So this acts as one of the raw material in steel formation. Then this is for specialty products and chemicals. Almost this simple. This is benzene and one hydrogen molecule phenol and one methyl molecule toluene and two hydrocyclic compounds naphthalene and 3 are anthracene. So the simplest aromatic structure of hydrocarbons is benzene. Different compounds are formed when different elements are attached to the benzene ring. So if it is OH, phenol, if it is chloride, benzyl chloride, and if it is methyl, this is toluene. So naphthalene is the simplest polycyclic aromatic compound. These and other compounds are extracted mainly from the carbon-based chemicals from coal. So these anthracite, the name itself giving the anthracite coal is like anthracene, naphthalene. So they contain only these black ones are carbons. So they contain most of the carbon atoms. So this is a hydrocarbons, aromatic hydrocarbon chains and polycyclic compounds. So they contain only carbon and hydrogen atoms. So these are mainly extracted from the coal. And this is industry and residential markets. In olden days, coal is used for cooking purpose to generate heat and energy. Now coal is still used in some industries and commercial boilers and ovens for heating and other purposes. The cement, glass and ceramic and paper industries still uses the coal. The cement industry is the dominant user of coal and cement manufacture is particularly energy intensive and where the coal is used. So these rare earth elements in the periodic table, we can see lanthanide and actinide series, which are nothing but the rare earth elements, REEs. Coal and coal preparation products are also potential source of rare earth elements because most of the ores like these rare earth elements are metal ores combined with the coal molecules in the earth's surface. So these REEs, rare earth elements are a group of elements in the periodic table. They include lanthanide series elements like cerium through lutetium, yttrium and scandium. All are obtained from this coal. So rare earth elements are trace elements in some coals and some coal-fired power plants combustion byproducts. So when during the extraction of these coals, the byproducts formed will have some rare earths. So these coals are indirectly act as a source of these rare earth elements. So these are the wide applications in industries as well as in thermal power plants, in blast furnaces, in steel manufacturing, in electric generation. The coal plays a vital role. So these all about the coal. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.